Next we will be doing energy stored in a charge capacitor. So next topic is energy stored in a charged capacitor. We will take the same example. Let us take a sphere which is given some positive charge, and this sphere will attain a potential V. So the potential attained by this sphere is equal to charge by capacitance. Now let us suppose you want to bring some extra charge on this sphere. Let us suppose you want to bring an extra charge dq on this sphere. For this purpose you have to do some work against this potential if this charge is positive. Now you want to bring this positive charge, small positive charge on this sphere which already has some potential V. So for this purpose you have to do some work. So that work will be dW, and that will be equals to, we have already studied that electric potential is equal to work done per unit charge. So here we can write V will be equals to dW by dQ. So dW will be equals to V into dQ. What V is equal to Q by C as in the above equation. Substituting that value, we will get Q by C into dQ. So that is equal to work done. So here to calculate the total work, we need to integrate on both sides. So when we integrate, we will get total work is equal to, here Q by C, 1 by C will be constant, and we will keep Q dQ inside the integration. So integration of Q dQ is equal to 1 by C is constant, so its integration will be Q squared by 2. We can also substitute the limits to this integration. Suppose in the starting the charge on this sphere was 0, and finally the charge on this sphere is Q naught. So we can substitute the limits. So when we substitute these limits, our equation will become W is equal to one by 2C Q naught square minus 0. That is equal to Q naught square by 2C. So work done is equal to Q naught square by 2C. So next we will be calculating the desired energy. So our work done is equal to Q naught square by 2C. This is the work that we need to do if we want to charge a sphere. So this work will be stored in that conductor, whether it is sphere or anything, in form of its potential energy. So this work will be stored in conductor in form of its potential energy. We denote potential energy by capital U, of course. So we can write potential energy is equal to Q naught square by 2C. Here Q naught is maximum charge that is given to that sphere. So in journal form we can write this equation as Q square by 2C. So potential energy stored in that conductor is equal to Q square by 2C. Now this formula can be written in number of forms, like if you substitute the value of Q, we know that V is equal to Q over C. From here Q will be equals to Vc. If we substitute this value of Q in this equation, we will get U is equal to V square C square by 2C. C and C will get cancelled, and you will get U is equal to half CV square. This is another very important expression for energy stored inside a conductor.